Hi everyone! In the last lecture, we calculated the input characteristics of a long channel MOSFET. In this third lecture on the long channel MOSFET, we calculate its output characteristics. Since the drain terminal is the output terminal, on the fixed gate voltage, the drain voltage is changed. We need several gate voltages. First, select a value and ramp up the gate voltage. Then, increase the drain voltage from 0 to VDD. A curve is obtained, but it is only for selected gate voltage. We must repeat this procedure with other gate voltages. This figure shows the result without any physical model. With 0.2 volt step, the gate voltage changes from 0.6 volt to 1.2 volt. As expected, the drain current is higher for higher gate voltage. Also, the triode mode and the saturation mode are clearly identified. Since the channel is quite long, the drain current in the saturation mode is almost constant. It means that the output resistance is very large. It is really an ideal case, so I wanted to recommend you to compare your simulation result with analytic expressions. Now, the inversion mobility model is introduced. Brown lines are the previous result without any physical model. The red lines are new ones with the inversion mobility. As you can see, the drain current is significantly reduced. The drain current at a gate voltage of 1.2 volt is even smaller than the previous result at 0.8 volt. Again, it is mandatory to consider a proper mobility model. Now, in addition to the inversion mobility model, the velocity saturation is further included. The blue curves represent those results. Since red and blue cases share the inversion mobility model, the difference between them is originated from the velocity saturation. As expected, in this long channel device, its impact is not that significant. Up to now, we have seen the IV characteristics. Of course, the device simulator gives us more information. This figure shows the electron density at the interface. These are source and drain regions. Since both the gate voltage and the drain voltage are VDD, the MOSFET is in the saturation mode. And we can clearly observe that the electron density at the drain side is much lower than the source side. Now, a short channel MOSFET structure is generated. The parameters are the same as our previous long channel MOSFET, except for the channel length. Instead of 1 micrometer, now it is reduced to 50 nanometer. Since the physical quantities change in a short distance, the spacing along the channel direction is reduced to 1 nanometer. The new short channel device and the previous long channel one are drawn in the same scale. It is clearly seen that the drain is much closer in the short channel device. Therefore, it is expected that the drain voltage may have some impact on the device performance. That's it for this lecture 12. In the next lecture, we will calculate the input and output characteristics of the short channel MOSFET. Thank you and see you later.